Let us talk about electrochemistry. Before starting electrochemistry, we should know about delta G. So delta G is basically the hidden work done of any system which it works. So the work done will be in negative. So this negative work done is basically the delta G, and delta G is represented as delta H minus T delta S. Before starting this chapter, we should understand that how the cell is formed basically. So before starting the chapter, we should do an experiment. What happened in this experiment is that a tank is taken and a strip is taken. This strip is of Zn, and a solution is taken. This solution is basically an electrolyte. An electrolyte is a solution which has ions and conduct electricity. This electrolyte is taken CuSO4. So this is the electrolyte. What happened is that scientists performed this experiment by engaging a temperature scale here. And after some time, they observed that this zinc rod becomes thin. This zinc rod becomes thin. What happens is that the first thing is that zinc rod becomes thin and becomes less, and the second thing is that temperature rises. The third thing is that the CuSO4 solution turns red from blue. Actually, it was blue, but after some time, it was converted from blue to red. So what happened is that we should understand that why this zinc becomes thin. So what happens is that the zinc gets converted down into iron and loses its electron. This electron is basically accepted by the ion that is present already inside the solution, and this gets converted down into copper. This copper seems to be red. Now during this, some work done is there is happening. So this work done proved that something is happening inside this solution, and this is known as the beginning of cell formation. Now before jumping into electrochemical cell, we should understand that what is happening here is that it is losing electrons. So here oxidation is done, and it is accepting electron, so reduction is done. So overall it is a redox reaction, right? Overall it is a redox reaction. And why the temperature is rising? Because there is something work done is happening, and this work done is released as heat here, and we don't know to release this as heat. We want to convert this heat into work done. Here is the beginning of electrochemical cell. Now this delta G here, because it is a spontaneous process, so here delta G is negative. Now see how the cell is formed. see how the cell is actually formed. So we can say the cell can be electrochemical cell because we are converting this chemical energy into electrical energy. That is why we are converting chemical energy into electrical energy. That is why we are calling it electrochemical cell, or we can call it a galvanic cell, or we can call it a voltaic cell. Right? Now, how to prepare a cell? This is the question. Where I'm drawing a separation here so you can understand it very well. So, you have to take two tanks with rod, and this rod now is known as the electrode. Electrode is basically of two types, cathode and anode. Based on reduction and oxidation, we will decide which is anode and which is cathode. Here in the left situation, I have taken zinc rod, and here in the right situation, I have taken copper rod, and I have taken same rod's electrolyte CuSO4, and vice versa, same electrolytes of the rod, that is ZnSO4, and I have connected these two electrodes with an ammeter. Now what happens is that based on electrochemical series, this Zn loses its electron. This Zn becomes thin after some time and gets into the solution and loses two electrons. These electrons get transported through this wire and goes to the copper strip. In this solution, copper 2 plus ions are there, and by seeing these two electrons, he will accept these two electrons, and after some time you will see that this electrode becomes thick. Why becomes thick? Because copper ions are deposited due to the addition of electrons, and addition of electrons is basically nothing but reduction. So this is a half cell, this is a half cell. So this half cell is known as reduction half cell. Reduction half cell. And vice versa for this is known as oxidation half cell. Also you can call it left half cell, because because electron are depositing here. Electron are depositing here. We will call this electrode as anode and this as cathode. Now, this is also known as anode half cell, and this is also known as right half cell or cathode half cell. Now what happens is that after some time you will analyze, this will become too thin and become zero. So according to this circuit, this will not complete, and after some time cell will stop. To maintain this situation, salt bridge is taken. Now what is salt bridge? Salt bridge we will discuss in next lecture, but before talking about salt bridge, I will tell you that salt bridge is a U-tube. Salt bridge is a U-tube which is basically nothing but containing inert electrolyte in order to complete this circuit and to neutralize the junction potential. In the next video we will talk about what is junction potential, Let's wait for the next lecture. Thanks a lot for watching. And if you like this video, please subscribe and make sure to like and comment on the video.